Hello everyone. So today we're going to cover a very important topic that you'll be using throughout your CS career. So we're going to be talking about repetition structures, specifically while and for loops. So we'll do part one today, and we'll do part two another time. So a repetition structure is just basically a loop. And we have two kinds of loops in Python. We have while loops, which are condition controlled loops, and they repeat while a specific condition is true. And then we have count controlled loops, and they repeat a pre-specified number of times. So we're going to look at both of these, and you'll be working with both of these kinds of loops. So first, let's start with a while loop. So a while loop is a statement that is repeated while this Boolean condition is true. So the way we write it out is we have this keyword while, and then we have a Boolean condition, colon, and then an indentation. So we do everything inside of this indentation while this Boolean condition is true. When we get to the end, we go back up to the top. We check if this Boolean condition is still true, and if it is, we do it again, and then we keep checking and we keep checking. If the Boolean condition is false, then we exit this block, this statement, and then we carry on down the code. So let's have a look at a simple example of a while loop. So I think the best thing to do is to copy this out. We can put it into Sublime. So you can put this into your week 4 folder. So you could call it while.py, or mine's called while_ex.py. So we have n equals 0, and then we say while n is less than 3. So this is our Boolean condition here, colon, print n, and then increment n by 1. So let's actually go ahead and run this and see what we get. So you can see here we have a printout of 0, 1, 2. So that's all well and good, but we want to understand what's happening on each iteration of the while loop and why we are getting this printout. So I think the best thing we can do is we can copy that. And then I'd like you to go to a website that we'll be using more and more called Python Tutor. And we're going to go into its visualize mode. So you can just Google Python Tutor visualize, or you can copy this URL. So when you get to this page, go ahead and paste your code in, and then we're going to visualize the execution, see what it looks like. So here is our code here. And then we're going to press the next button, and we're just going to keep stepping through the code. So let's have a look. So the first thing that happens is that this variable n gets created with this value 0. And by the way, the red arrow is always pointing to the next line, so it can look confusing because it's like, oh, I haven't got to that line yet. But that's what is pointing to the next line. So n has been created here. Then we're going to check, is n less than 3? And I think we all know that 0 is less than 3, so that's true. So we can go into the while loop. So this next line, we're going to print n. So there's the printout, 0. Then we're going to increment n by 1. There's the incrementation. And then we go back to the top of the while loop and we check, is n still less than 3? And it is, because it is currently 1. So then we go down, we print n, which is 1. We increment n by 1, so now it's 2. So this is like representing the variable and the value being held in memory here. And this is the printout. We go back, we check, is n less than 3? Yes, it is. So we print n again. So there's the 2. and then we increment n by 1, there's the 3, and then we go back up to the top and we check, is 3 less than 3? No. So then it's going to exit out of the while loop. So that's what's happening. So when we run the code, that's why we're getting 0, 1, 2. And I think this Python tutor visualizer is a really good tool for you to understand what's going on in the back end inside the memory. And that's something that you're definitely going to need to know when you're working with loops and functions and so forth. Now, something that you need to be careful of is the infinite loop. It can happen quite easily by accident. So I'm going to show you an example of an infinite loop so you can see what happens so it doesn't happen to you. Or if it does happen to you, you can recognize what's going on. So you can see here in the earlier example, we had a way to terminate the program when n was no longer less than 3, it was going to be false. Let's have a look at this program. Infinite loops occur when the programmer forgets to write code to make the Boolean condition false. So here we start with n equals 1, and we say while n is greater than 0, print n and increment n by 1. So let's run this. You can run this in the same file that you had before. Let me just take this. I'm going to make it the same as this is here. Okay, good. So let's run while, and here we go. You can see that it keeps going and going. It's just going to keep going till I run out of memory and it crashes. So I'm going to stop it. If you can't stop it, you can just close your terminal. It's okay. But yeah, so you can see here, it's just going on and on and on. So what's happening here? So let's have a look at this code. We can actually copy and paste it into Python tutor visualize. So let's go here, paste, this is the new code. Let's say visualize execution. So we start with n equals 1, and then we check, is 1 greater than 0? It is. So we print n. There's 1. Then we increment n by 1. It's 2. And then we check, is 2 greater than 0? It is. So we print n. And then we increment by 1. So maybe you're seeing here what's happening now. Oh, here we go. Look, it said, stopped after running 1,000 steps. Cool, that's funny. But you can see here, as we go on and on, it's never going to end because we started at 1, which was already greater than 0, and then we're just going to be incrementing n all the time. So it's never going to be less than 0. It's never going to stop. And that's why we get an infinite loop. I also want to show you, so I want to actually take out this print and put it outside the while loop, and then I'll have you run it again. And then you can see here, I just get this flashing prompt, but there's no printout because the print statement is outside of the for loop, of the while loop. So we've never even got to the print statement yet. So I'm going to stop this because I don't want everything to crash. But I just want to show you that it is possible for you to have an infinite loop with no printout. So you need to watch for that as well. Okay. So let's look at another while loop example. So suppose you want to make a cup of oolong tea where the perfect water temperature is 88 degrees Celsius. You want to simulate the water cooling down and print each temperature until it reaches the perfect temperature. So we start at boiling, so temperature equals 100, and we say, while temperature is greater than 88, print temperature and decrement temperature by 1. And then when it's done, it will print your water is ready for your oolong tea. So let's copy this and actually run it, first of all. So here's our code, and I'm gonna clear this. Okay. So here we go. We start at 100 and we go down and we say your water is ready for your oolong tea. So remember the print statement is outside of the while loop, right? Okay. So I have a question for you here. Is temperature equal to 88 or 89 when the statement is printed? Why? And how can we check it? So here's the output, right? And here's the code. So what do you think? Is it going to be 88 or 89? Well, there is actually a easy way to check it, and you can always do this and check things and add things to your code. So what we can do here is when the statement is printed, we can say temperature and run it again. And you can see here it's 88. And the reason why it's 88 is because after the last print and the last check, it decremented once again. And the reason why it was able to stop at the correct place is because it was greater than 88. So when it was 89, that was greater than 88, it printed 89 here. It printed 89, and then it decremented again here. So when it was printed out finally, here it was 88. And the final question is, what would happen if temperature is greater than or equal to 88? Well, then it would keep going until it was 88. And then it would print 88, and then it would decrement by 1, and then it's be 87. So the reason why I'm just showing you these things is when you're working with loops, first of all, it's really important what you use here for your booleans, so greater than or equal to. And second of all, it's really important the order of where you put your print statements versus your incrementations or your decrementations. So these are all things you have to really watch out for to make sure that you're doing things in the correct way so you're getting the output that you desire. Okay. All right, so now let's look at for loops. Now, this is a count controlled loop, so it does it a specified number of times. Now, this is an example with a list, and we're not going to do lists yet, but we wanted to show you that you can do this with a list, and we'll come back to it later in the semester. But the important thing about for loops is that you have this keyword for, and then you always have a target variable here, and then you say in, and then here you don't have to, but here we have a list, which is denoted by the square brackets, colon, and then we have the indentation for the statements. So let's have a look at an example with a list. So we can actually copy this in to Sublime. It'll make it a bit easier to understand. And I'm actually just going to comment out this stuff, and we'll just look at this first lines here. All right. So print the numbers 1 through 5. So we say for, and then we have our target variable here. We can call it whatever we want. Here we're going to call it num. And then our keyword in. And then we have a list denoted by these square brackets. And what's going to happen is this variable num is just going to be assigned the value of each of these items in the list, one at a time, one for each iteration of the for loop. And inside the for loop, we're having it print num. Well, let's run it first, and then we'll try to understand better how it works. So let's say Python 3, what do we call this? 4.py. Okay. So you can see here, it's for each iteration of the for loop, it's printing out num, and each iteration of the for loop, num is being assigned the next value in the list. So if we copy this code and we pop it into Python to visualize, we say visualize execution. So we go next, so it's going to print this first line, and then we say for num. So you can see here now this variable num gets created in memory. and it's assigned the first item in the list, which is 1. So then we're going to print num, which is 1. We go to the next one, and now num is equal to 2, which is the next item in the list. So we're going to print num, which is 2. Then the next iteration, we go back up to the top, num is going to be assigned 3, like this. So you go and print num. Next iteration, it gets assigned 4, and so forth. And then on the last one, it's assigned 5, it's going to print it, and then it's going to automatically stop because it's the end of this list, right? So that's how it looks on the back end. So on each iteration, you can fill this in. Num is 1, 2, 3, 4, 5. So this one's a very straightforward example. You can also try it, with odd, just listing odd numbers. Like here's your list, 1, 3, 5, 7, 9. And you can go through on each iteration and see what they get assigned and what gets printed out. And this one, we're not going to do strings till later, but you can think of a string like a list of characters. So here, if there is this huge string, which is a whole alphabet, each iteration of the for loop, this target variable will be assigned 1 character at a time. So when it says print letter, it will print out each character in the alphabet one at a time. And you can please go ahead and try that in your own time. But this is what I really want to focus on, which is the for loop with the range function. So we're going to be using the range function. It's a built-in Python function a lot. And I really want you to get familiar with it and be able to use it. So it says here the range function creates a type of object iterable that contains a sequence of values that can be iterated over with a loop. That's all well and good, but really you don't need to worry too much about that. We're not going to do object-oriented programming till the very end. You just know that the range function allows you to iterate over a loop. The really important thing to know is this end plus 1. So you must learn this. It's non-negotiable. And if you don't learn it, you're going to have so many problems throughout your semester. So we have this set up where we say for, and then the target variable in, then we use range, and then we give this some value, which is going to be end plus 1, and then indent, and then all these things we want to do. So for example, we could say, print the numbers 0 through 4. And we say for num in range 5, print num. Well, let's go ahead and run it, because I think that's always the best way to see what's going to happen. If you're wondering what I'm doing control / to uncomment and comment, by the way. So let's run this again. So let's have a look. Print the numbers 0 through 4, and we go through, and we have for num, the first value of num, you can see here when it gets printed is 0. And that's because range always default starts at 0. And that's just a thing about range. You just have to learn it. It default starts at 0. Let me see if we carry on here. No, okay. So that's one of the things you have to learn is if it's by default, when you're working with range, you're going to start with the value 0. Okay. Then we're going to go back to the top of the for loop, and then we go through again. And now this time it's going to equal 1 because it was just iterating through. And it's going to keep iterating through each time, 2, 3, 4, until it hits this end plus 1. So in this case, the end is 4. So in the range, we have to put 4 plus 1, which is 5. And that's what we're talking about when we're saying end plus 1 here. So whatever number you want to end on, like if you want to end on 4, you have to add 1 to it inside of the range. So let's actually have a look at this. Let's copy this in to Python Tutor Visualize. Let's go back here, copy this in. All right, and visualize execution. Okay, so we'll click next. So we start for num in range 5, and you can see here that the target variable num is assigned this value 0. So then we go to the next line, print num, so it's going to print 0. Then it goes to the next one and iterates, goes increments. So we have num equals 1. We go to the next one, we print num, and then we increment. We have 2, print, increment, 3, increment, print, 4. That's going to be our last one. We're going to print that. And then it just stops after that because range 5 is the last one. It's end plus 1. And that's the thing that you're just going to have to learn and get comfortable with. And I know it's a bit weird, but it's going to make more sense why it uses this n plus 1 later when we do lists. You can also use it to do something like a certain number of times. Like you could say, for x in range 5, print hello world. So if you did that, you would end up printing something 5 times. And I'll show you this. Let's run this real quick. So here we go. Hello world, hello world. But let's actually copy this and have a look at the Python tutor visualize, because I want you to see something that's happening in the back end. So as we go through, see here, x is given the value 0, right? But we're not printing x, we're printing hello world in this example. But x is still incrementing in its value in the back end. And so you, in this class, as a computer scientist, you're expected to know what's happening with x on the back end, and on each iteration, what value it's going to have. Okay? And we'll come back to that a little bit more about iterations and knowing what's going on. The other thing that you want to know about the range function is that it can take 2 arguments, and if it does, the first argument is the start argument, and then the second one is the end plus 1. So you know how before we were saying that you can default start at 0? So if you don't have a starting argument, it will default start at 0. But if you do, then you have to start at the specified number. So if we wanted to print the numbers 2 through 6, you could say for num in range 2, 7. So let's have a look at that. Here we go. So let's run this. So you can see here, it starts at the number 2. It no longer starts at 0, and that's because we've specified this 2, and then it finishes at 6 because we've said 7, so it's 6 plus 1. And you can also run that in Python Tutor if you wish. And then finally, you want to know that the range function has an increment value argument. So a third argument. And this tells you how to increment. So far, the default has been to increment by 1. But you could also increment by 2 or 3 or decrement by 1. So this argument is for that. So for example, we could say this, print the odd numbers between 1 and 10, and we start at 1, we finish at 10, and we increment by 2 to do that. So let's run that, and you can see here we'll start at 1 and then it will go up in increments of 2. Yeah. And then important one to know is you can also decrement by 1 if you put a -1. So if you wanted to count down from 10 to 1, let's have a look at that in the code. It's easier to read. If you wanted to count down from 10 to 1, this time you would have your starting argument as 10. This is now interesting because I'll come back to this. And we have our decrementing argument as -1. So let's run this. And you can see we start at 10 and we decrement by 1. And then you see how we finish at 1, but this is 0, right? So here it's almost like end -1 here, because we wanted to end at 1. So we said 0 is our finishing here. And you can play around with this and see if we had put a 1 here, what would happen? Then we'd finish at 2, right? So if we put a -1 here, we'd finish at 0. So it's just good, especially for next lesson, for you to see what's happening when we decrement. All right. So this is just summarizing what we just said. So your for loop with your range has a start, n+1, and increment value up to 3 arguments, and it starts at 0 by default and increments by 1 by default. I also wanted to show you a for loop that was actually generating a table. So we can have a look at this. You can copy that into the code and have a look. So for example, here we are using the tab. Remember we introduced that a few lessons ago to create a nice space between our columns. And then we're using our for loop and we go from 1 to n. And that's the nice thing, is we can also use n like that as an argument inside of range. And then we want to print x, have a tab, and we're squaring x. So let's have a look. Clear this. Python 3, and go table. So you can see here, that's what it's outputting here on each line. So the first iteration, x is going to be equal to 1. Second iteration, x is going to be equal to 2. So you can see it's just incrementing up till n+1, 11. So it's going to stop at 10. So you can take some time and study that. Make sure that's clear. Now this is very important. We're going to talk about accumulators, and I will be referencing accumulators for the rest of the semester, so please learn these. So an accumulator calculates a running total. So a running total can be a sum of numbers that accumulates with each iteration of a loop. So let's have a look at a piece of code that does this. Here is the sum of numbers from 1 through 5. And then we start with our accumulator equal to 0 here. And we say for n in range 1 through 6. So we start with 1. We're going to end at 5. Total equals total plus n. Now it's really important that you understand what this line means. So if you're not sure, please write it out. So the new total is going to equal total plus n. So make sure that you're clear on what that line means. And then outside of the for loop, we're going to print total is, and then the total. So let's run that first of all. So we see what's happening here. Here is the sum of numbers from 1 through 5. Total is 15. Okay, it's not super helpful. So let's actually step through step by step, seeing what happens in this way. And I want you to actually please write this out with me, because it's really important that you learn how to trace through your code, through the different iterations. So let me just get set up. You can get a piece of paper. Okay, so I'm going to say iteration, and up here I'm going to say initialization. And then we're going to have this variable n, and we also have the accumulator variable total. Okay. So in our initialization, total equals 0. So we've initialized total before the for loop, right? Total equals 0. Okay. Then we go inside our for loop and we start with iteration 1. So when I say iteration, I mean each time we go through the for loop. So the first time we do this, we know that n is going to equal 1, right? And total is going to be, and let me write this out. So for those of you, total equals total plus n, right? So 0 plus 1. Okay, let's go back here. Great. So then we go back. Gee, I wonder if we do this so you can see the code at the same time. That would be much better, I think, if we can do that. Okay, good. All right. So now you can see the code at the same time. Okay. So that's the first iteration of our for loop. We go back up to the second iteration. Oh, yeah. And then we're going to say n is going to equal 2. Let me make this a bit smaller so we can see both at the same time, hopefully. This. Okay, good. So n equals 2, and then total equals, move this, total plus n, remember? So it's 2 plus 1, which is 3. So this is our accumulator total. You can see how it's accumulating the values. We go into the third iteration. Now n equals 3. So we say n plus total, 3 plus 3. Now total is 6. We go to our fourth iteration. Now n is 4. We say 4 plus 6, 10. We go to our final and fifth iteration. N is 5. 5 plus 10, 15. And that's what gets printed out here. Total is total, right? If I go back here, we can actually check this by doing this. Let me get my keyboard back. I can actually add a line here and say print total inside. And then when we run it, you can see on each iteration what total is before the total is printed. So that is us working with an accumulator. So that's really important for you to learn. So please make sure you learn that. If you have any questions, please let us know. Okay. So now you have enough information to be able to do in-class exercise 5. So let's have a look at it together. So first one's pretty straightforward. Write a program at add_2.py starting with I equals 1 and use a while loop to add 2 on each iteration of the loop until it reaches 9, not including 9. Print the value of I on each iteration. It's up to you whether you want to print I when it's equal to 1. So this is just using a simple while loop just to get you going on while loops. Now write a program, another one, sum_range.py. So you ask the user for 2 integers, right? So 2 inputs, A and B. Then compute the sum of all integers greater than or equal to A and less than or equal to B. If A is not less than B, your program should print out an error message. Okay, so here we have the sum from 1 to 10 is 55. So if they entered 110, 10, 100, minus 10, 3. And then here it's if they A is not less than B, then you should print error 10 is greater than 4. So that's that one. So obviously we're going to need some kind of for loop here to do that, which we just did together. So you can use that. Just be careful of your end plus ones when you're doing that. And then finally, write a program factorial.py. This code should prompt the user for a value and then print out the factorial of that value. Like they can ask the user for n, and then you want to print out n factorial. So n factorial is, 1 times 2 times 3 all the way up to times n. It's fine for 0 factorial to be defined as 1. So here are some examples, like 1 factorial, 1, 2 factorial, 2, 0 factorial, 1. With this one, I would say obviously you're going to need, again, a for loop with an accumulator, but just be careful of what value you start with your accumulator. Because, for example, here we started with our when we were doing addition is total equals 0. But you want to think about with a using 0 is suitable when doing multiplication. So, yeah. Now, this extra credit is actually quite tricky, but it's really nice. So, write a program power.py. This code should prompt the user for 2 numbers, a base and an exponent, and computes the power using the base and exponent using a while loop, and obviously not the power operator. So you have to use a while loop for this one. So for example, we say enter a base, enter exponent, 2 to the power 10 is, right? So here are some examples that you can use. And this is a nice one. Feel free to create variables as needed for this one. All right, so it's okay if you don't get to start on in class 5. We can go through this together in class and enjoy working with for loops and while loops. And we'll leave it here.